Alrighty, g'day. It is PowerShell, it is Saturday and it's PowerShell 101 live time. It is a very tough morning this morning. Definitely on Struggle Street. Just gonna do a quick audio check, make sure everyone can hear me. Yep, sweet. Yeah, I missed my flight last night, and so I was sitting on a plane full of school kids. But at the end of the day, though, just use it as an opportunity to finish the slide deck for this course, so, for this specific lesson. So essentially, yep, today 101 Live, we're going to be covering predominantly the main, obviously keynote, if you'd call it, would be looping. Everything else is kind of all just those other little shenanigans. But I think it's just we're going to be also doing just a quick recap and some other bits. So we might as well get started. We're going to break into it. So first things first, I'm going to actually shrink my presenter view so I can actually change my scenes in OBS. And right, we are in. Sweet. Alrighty, so I'm gonna get rid of that. Credits, get rid of him. I don't need him anymore. Yes. Okay, cool. So I just quickly removed bensound.com. I don't really use them anymore, so we're just gonna. I'm using Spotify, no copyright music, I think is the playlist. So anyway, that all aside, welcome to 101 Live. So yes, so today we're going to be covering just a quick recap from what we did previously. So we obviously are going to be extending into a lot more into the looping. So we have to make sure we have a quick recap of conditions, things like that. We're going to have a small intermission for 5 minutes, so people can kind of stand up, have a bit of a break, go for a walk, and then we'll kind of get back into it. And the main topic of this talk will be the PowerShell and Looping. So essentially, this again, 2 hours. This is dense, very dense content. Lots of demos. So sit back and get ready. Also, with regards to the sorry, I'm just trying to think. If you want the slide decks, things like that, just message me on Twitter or message me in channel, and we can basically link them up for you. So essentially, it's all free, it's all available. You're learning PowerShell. That's really the main thing. So let's get stuck into it. So obviously, to reinforce skills, it's always better for a person to basically do it themselves versus being able to kind of sit around and just watch. So obviously, applying your knowledge is much more effective than just watching. So there's an assessment. Same thing, a bit of homework. It's not that hard, but essentially, we're going to use. I want you guys to kind of just using Client Hyper-V. I want you to create a VM. I want you to install Windows 10 on that VM. I then want to obviously, using that VM, I want you to install OBS Studio 24 and then obviously VS Code. G'day, BB. So essentially, yeah. So with questions or anything like that, you can feel free to interrupt with questions, things like that. Obviously, it's fairly relaxed. We're in a fairly informal environment, but obviously if there's a lot of questions, we're probably just going to have to pick and choose. At the same time, I don't have time for discussions, so we've got a lot of content to cover, and there's not going to be unfortunately there's going to be not really many discussions. It's going to just be more of a lecture. So PowerShell, quick recap. So essentially, we're just going to be talking about equality operators. So we have our first equality operator. We've obviously talked about this in the previous lessons, but we're just going to quickly go back and reiterate because we are going to be using these a little bit more now. So essentially, we're going to have our equals. So it's essentially in anything other languages, you got VB or C#. It's the same operator. In JavaScript, you obviously have different types of it. You've got your doubles and you've got your triples, and they obviously denote different types of comparisons. But essentially, it's the same thing. Obviously, not equals. It's obviously the reverse of the equals. So if B is not equal to A, then the condition is evaluated to be true. So it's fairly straightforward. Greater than, so 2 is greater than 1, that's obviously true. So basically, again, you're comparing two values. Now, this is not just limited to integers, it can be dates and things like that as well. So essentially, if it's something that PowerShell can measure, like a date, so if you've got yesterday is greater than today, no, that's going to evaluate to be false. But if yesterday is less than today, then that will evaluate to be true. So you can compare other object types. So obviously that corresponds to the following one, which is less than. 1 is less than 2. I generally just use integers, obviously, for people to be able to articulate, but essentially you can use dates or whatever you want. It's really quite cool. Obviously, greater than or equal to. So 2 is greater than or equal to 1. That's true because 2 is greater than 1. But if we said 2 is greater and equal to 2, that would also equate to true since it's basically equal to. So that's really quite handy, those ones to have as well. And obviously less than or equal to. So that's pretty much equality operators. I'm not going to spend much time on that. We kind of covered it previously. So if you want to go view them, just jump on the Brisbane PowerShell user group channel. And I think it's in the lesson, we are in lesson 4. I can't remember what lesson we are in now. What lesson are we in? We're in lesson 4, so I think it was in lesson 3. So check out lesson 3 for more of that. So what I'm going to do is clear all this. Erase all icon slide. Let's go to the next one. So where object. Again, I'm kind of just trying to use, obviously we're just going to be recapping some elements. So where object is basically used to filter input from the pipeline. So essentially you can have an item, or you can have a collection or an array. We're just going to use an array. That's supposed to be $, and then we can actually pipe that into a where object. Obviously I'm just going to use the alias because I can't write where object, and then we have our script block, which we would do our code inside of here. So essentially, you have multiple ways of performing your condition. So your expression. So you can have a traditional script block, which is what most people follow, even though it's PowerShell 5, it's pretty much changed. You can pretty much just say, where object property condition value. So you can have your property name or your object property. You can have your condition and your value. So your property could be like $_.name and then equal, so hyphen EQ 1. So that basically you don't necessarily need to use the script block. The script block's very handy though, because obviously it helps us to be able to actually write more extensive and more, we can actually write nested queries. So we can basically use our ands and our ors and our nots and write some very, very complicated logic to be able to actually do some very, very, very powerful filtering. So essentially that's our where object. Write output. So this is one that I kind of need to talk about for a little bit to make sure everyone's across. But again, it's kind of something that we need to reiterate. So write output is used to explicitly return an object, a collection, or array to the PowerShell pipeline, a value to the PowerShell pipeline. So it's really, really important because what it means is that when we're using write object, we can actually pass that output through to the next item within the pipeline. Now, one of the things with write output is the fact that when we're using write output, if we have an object or an array or something that's not declared in a variable and it returns to the what we call to the script block or to the script, and it's not declared or stored in a variable, it would be calculated, it would be treated as a write output. And what that basically means is you don't necessarily have to use it. It's just a really good way to communicate when you're writing code, to be able to say, hey, I am putting something onto the pipeline versus kind of trying to go through and find it. So a really good example of that. Let's have a quick look. I'm just going to quickly jump into a demo just to show you guys. It's only going to take 2 seconds. So essentially, I'm going to stop that piece of code. Oh, it's already stopped. Essentially, just going to create a new file here. So I'm just going to bring that over there. Essentially what we have is we will have a, just going to declare an array. Actually, we're not going to do it in there. We're going to do, I'm going to go, oh no, sorry, never mind. Demo. So essentially, what we'll have here is we'll just declare an array. So we can have an array. Like so. And basically, if we do a write output, that's going to return to the parent, which is basically the PowerShell actual pipeline, or the pipeline itself, which will then return. That's fine. But to actually articulate this a little easier, what we can do is, I'm just trying to think what's the easiest way to do this. Okay, let's do this. What we're going to do is we're going to iterate through each of these items within the array. So we're just going to go, we'll cover this later in the thing, so I'm just going to do a quick for each object. We're going to iterate through each of the elements within the array. We're going to use $_ to get the current object within the array. And then we're just going to do a write output. Like so. So essentially, if we run that, you can see it returns 1, 2, 3, 4, 5, 6, 7. So essentially, it's just writing out. Now, if I don't do that, and let's say we say write host, let's just go. Let's do another for each object here. And what we're going to do is we're actually going to pass that info into here, and we're just going to say write host, like so. And we're going to pass that item into the following array. We should see it go write host 1, 2, 3. So essentially, we're iterating through a loop, and we're pushing all those values back into the array. Into the pipeline, and then we're taking those values back from the pipeline and then basically passing it to write host. Now, it also applies if we do this. So if we grab, if we do this, and we actually just remove it. So we're not actually storing it as a variable, we're just basically plopping it there. Because it has an output, it actually is treated as a write output. This is. Now, this is really important because you're going to see you're going to see people, or you're going to see situations where there's something returning to the pipeline when it shouldn't be, and it's always going to be due to something like this. So if you don't want it to write out, you either can use a null or an out null. So essentially, or put it in a variable. But if you're going to put it in a variable, it's just easy to put it in a null like so. So if you do that, then basically it won't. Because it's just nulling, nulling it out. So what we can do is this won't. And so if we rerun this, it actually won't run write host at all. It'll just do nothing. So you can see there, it's run, but it hasn't done anything. So cool. So that's basically write output. We're going to jump back into anything. So I'm asking for questions. Any questions for write output? So I'm just going to quickly pause for about a minute. So we'll give you a couple of seconds if you've got any questions. While waiting on that, I'm just going to kind of get the next slide. Okay. All right, a couple more seconds. All right, let's keep going. So PowerShell conditions. So we're just going to cover a couple of PowerShell conditions. We're going to be looking at the if statement, the switch statement. The reason why we're going to be looking at this is because in the following lessons, we're going to be basically scripting with PowerShell. We're actually going to be writing some code, some rudimentary code using these conditions. It's really important to understand when to use both because they both have their uses. So one of the benefits is we can write some very complicated, I'll say complicated, but very precise conditions, and we're going to actually see some of these in demos. So let's get stuck into it. We're going to be talking about if, else, and else if. So essentially, these are used to check the condition of a script or a function. So if you have a if, it's basically used pretty much to do any sort of logic check. If you want to do any sort of control flow. So essentially, if you want to be able to take a action, test that action, and then do something else with it, that's really the intention for an if, else, else, if. So you can see the statement here. I'm just going to quickly go into the pen. We've got our if. Now, if is always, that's obviously a mandatory. And then we obviously have our condition. So our condition is basically our any sort of conditional operators. So we can basically use equals, we can use the net, we can use contains, any of those equality operators we can use. Now the cool thing about it is that basically when we're using them, we can actually obviously build quite complex if statements. So we can basically say, okay, if it's this, or if it's this, or if it's this, or it has to be this and this and this, or so you can create a variation in terms of the condition block is pretty much whatever you need it to be. So you can write some very easy, very cool if statements. It also helps you refactor your code and make it more maintainable. So essentially, matching, once we've had that, then basically we have our first script block. So this is basically the condition that is evaluated to be true. Now, when I'm obviously using true in the inverted commas, it's basically if PowerShell naturally evaluates, will naturally evaluate to be true. The only time it doesn't is with a until block, but that we'll talk about. So essentially, or one person called it's naturally optimistic. So essentially, this is your matching condition value. So we talk about whether it's true, but essentially it's just your matching condition. Most of it will be true. You will flip, and you can flip it and make it false. So if the file doesn't exist, then basically you can do that. And so you're testing for the false, but essentially whatever's matching is really what it's going to execute. So this will execute the following code. You have the else statement. So the else statement is basically the non-matching condition code to execute. Now we'll talk a little bit more about the else statement, but it's really, really important to articulate that basically the else statement falls after the else if. So one of the things you can do in PowerShell, and obviously a lot of other languages, is you can actually reevaluate. So in here we can actually say we're going to use an else if, and we can actually do some other matching condition to match and to execute those pieces of code. Now this is really handy to write what we call you can write specific variations of logic. And so what we can do here is that when we're actually when we're doing very complicated if statements, we can use our else if to actually help us along with that process. So instead of having if else blah and then having all these kinds of this weird switch setup where you would have well, this is false and this is true, you can actually just nest all these statements. Now there is obviously the switch statement, which we'll talk about, but essentially else if is a very, very powerful very powerful statement. So conditions in an if statement can either be true or false. So what I mean by that is, so when you're actually evaluating a condition, so for example, if you have an item in a collection, it's either going to return true or false. If you have a value that exists or it doesn't, so if it's null or if it's not, then basically it's true or false. So the way that PowerShell will look at it is if you have, for example, let's say we say if string, so if we have an if hello is present, it'll basically say, yeah, well, hello is present, then it's true. So it's really basically conditions really can only be true or false. So as you can see here, we've got an item in a collection. We're using the in condition is true, do something. As simple as that. Now, if we use not in, then the condition would be flipped, but essentially it's technically true because basically the item is not in the collection, therefore it evaluates to be true. A little bit of a mind bender, but yeah. Now, else would be technically the false equivalent, but essentially whatever the condition is what you're measuring on. So if you're measuring on if item in collection is true, and then let's say you flip it, then basically then it still is true. Like it'll just flip the value in terms of it'll flip the condition, and then so you can then evaluate whether you can then flip the condition, and then it will evaluate to be true or false on the output of that. So what I mean by that is, let's say if we put a not here, we actually just put a not. I'm just going to use an exclamation mark, signify a not, and then we wrap it in another bracket. Oh, sorry, in another parenthesis. Obviously, if item in collection is present, which let's say we assume it is, it will flip it because of the not, and then basically will say no. So it would be the equivalent to have a not in. In that circumstance, okay, you have the first execution here, which is the item in collection. That's evaluated to be true. Now, once that parenthesis, so that execute or that condition has been completed, it will then evaluate against the not. So when we're evaluating against the not, then basically it's going to flip it. So it'll flip it to, if it's true, it's going to flip it to false, and then basically it actually won't execute this. Now, if it was the other way around, this is the mind bender. If it's the other way around, and let's say the item wasn't in the collection, it will flip it. The initial condition or result, the condition result within the first set of parentheses is false, but the not will flip it to be true, and therefore will satisfy the condition, and therefore execute this code. So you can do some very, very funky stuff, but essentially it's really, really important to know that conditions can either be true or false, and it makes it a little bit easier. All right, so like I said, the else if is used to reevaluate additional conditions. And so what I mean by that is essentially you can have multiple nested else if statements to evaluate other specific conditions to that. So a good example is we have an item in an array, do something here, or we have another item in an array. So it's the same, still the same array. Notice this is the same array. So think of it as you've got number 1, do something here, you've got number 2, do something here. So essentially you have two separate pieces of logic that do completely separate things, but you need to be able to test for either 1 or a 2. So if it's 1, I want to like create a file. If it's 2, I want to send a message to the user. So that's basically a really good example of how an else if really is functioned. How it functions. So one of the things you can see here is you have an else if, and it always comes directly after an if statement. So the flow is an if, then it's an else if, and then it's an else. And so essentially you can nest as many else ifs as you want within this. So you can go else if, else if, else if. Like obviously it's not the best, but essentially you can. And then within that you can basically create a very, very detailed you can create a very, very detailed statements. So you can have, doing completely different things. And that's really what it's used for. Now, I'm just going to quickly stop for a second because I'm pretty sure I had demos, and we're going to be going doing some demos, and I kind of forgot about the demos. So what we're going to do is we're going to go to VS Code and we're going to go to the demo. So essentially we have our if statement. So I've got here an array. We're just going to execute that and drop that into memory. I'm just going to clear the screen so everyone can see down the bottom here. And as you can see here, we have if 1 is in the array. We know that 1 is in the array. We can see that there. So what we're going to do is we can run that, and we should see a right host success. Okay, perfect. So that's basically a basic if statement. Now, if we were using a not, we're going to actually, like I said before, we're going to flip it. Now, because we're using a not, this is really an interesting condition, because 1 is not in the array and then we've knotted it. So what's going to happen here is 1 will this initial condition here will evaluate to be false because it's not in the array. The following, obviously, since it's nested inside a parentheses, and we have a parent not, the not will flip it from a false to be a true. So what that means is this will actually write a success to the screen. So if we run that, we can see success. So that's a really good example of what I was talking about when we're using a not to flip it. And you're going to see that in certain circumstances. One of them is if we're using test path. Test path is actually an excellent example. The reason why is because test path is a Boolean commandlet. And so what that basically means is it either returns true or false. And so this is how I can actually write that specific if statement. And so what that means is that I don't actually have, I know that test path is either going to evaluate to be true or false. Now we know PowerShell naturally evaluates to be true, so this will work. We don't actually need to add equals true because PowerShell naturally does that. It naturally evaluates to be true. It's naturally optimistic. Now, if, let's say you want to write some code, for example, let's say there's a use case. The file doesn't exist. Throw an error. This would be a really good use case. Now there's a couple of ways you can write this. Essentially, this is the way I write it because I find that it's easiest to understand. So I'm going to flip it with a not, and then I'm going to basically say literal path. We're just going to say y because it doesn't exist. And we're going to throw in it. We're going to write an error. So essentially, what we're doing here is we're saying test literal path is y. That's going to return to be false. Test literal path, the file doesn't exist. It returns false. But we want it to execute in the first statement. We don't want to execute it in the last statement or inside an else statement. So what we're going to do here is basically we can use the not to reverse the two. And so now we can just basically do that, and now we get an error. File doesn't exist. And so that's a really cool way of being able to actually say, hey, testing a file where doesn't exist. Another way you can do it is by doing this. You can basically say, some other people might do this, and they might just say equals false, like so. That's another alternative because you're explicitly declaring the false, but it's really each to their own. So if I test that, you can see that's going to throw an error. I like it this way. I feel like it's just a little bit more succinct and to the point, but there's no real wrong way. They do the same thing. This is just feels like we know that the test path already naturally evaluates to be true or false, and we know that PowerShell is naturally optimistic. So the only thing we need to do is flip the bit. All right. Now we can actually use the if statement to find an element within the array, and we can actually say whether it's a failure. So in this instance, if we basically say we have an item 1 in the array and we want to specifically perform an action for that item number 1, so if we declare array and we're just going to run that, we're not going to see anything. We can see the code executed, but we actually never saw a write host, and obviously because it doesn't exist. And that's a really good example of the demo for if. All right, let's jump into else if. So else if, we're going to actually we're going to go pretty deep now. So we're going to do an initial demo showcasing else if. So we have here, if 8 is equal into the array. So we have an array here from 1 to 7. Is 8 equal into that array? No, it's not. It will not execute. The second thing we have here is an else if statement. So we've actually declared an else if, we've specified an else if is 1 in the array. Well, yes, it is. So we know that 1's in the array, it's going to do that action. So if we run this, we should see, yep, there's a write host success. So that's basically a really cool, important thing to remember, is that basically This is really good for evaluating, like I said, you have a different item or a different code execution that you need to put in there because of a different value. So for example, if the file exists, you know, if file A exists, you want to do this. If file B exists, you want to do this. And you can do really cool things like that. So essentially, if you've got an array, you got like, let's say 1 to 5. If it's between 1 to 5, do something like, you know, put a counter. If you have from 6 to 10, do something else. And anything over 10, throw an error. So let's look at another practical use of else if. So let's consider the following scenario. So you're reading content from two files. Now, depending if the content exists, you're going to perform different actions. This is a really good example. However, this presents a problem because there's actually 4 scenarios that we need to cater for. Both files need to have, the first scenario is both files have content. The second scenario is the first file has content, but the second file doesn't. The third scenario is the first file doesn't have any content, but the second file does. And the fourth scenario is none of them do. And this is basically where else if comes into the equation. You want to be able to do specific actions with two different entities and be able to articulate that. So essentially an else if helps us describe those specific actions and be able to actually do something. So essentially here I've got some mock data. I actually don't have any mock data, so this is going to basically execute to the 4th block. I'm just going to do an error action silently continue because it's going to throw errors. So what we got here is some mock data, and we're going to run it. As you can see, both elements are null. So what we're actually testing here is the file null? Is there anything in it? Is it just an empty object? And both of them are empty, so we know that it's going to satisfy this first condition. Now note that I've wrapped the conditions in a parenthesis. Basically what we need to evaluate is this null? And what we're doing is we're basically producing a true or false value and a true or false value here. And then I'm using the AND statement to validate those two other statements. And so both values have to be 0 for it to be, both values have to be false. Both values in this situation, which is files equal to null. So if both of the files are null, then it will satisfy it. Now, if one file is null, it's not going to work. So it's just basically, that's a really, really easy way to kind of articulate. Obviously, we have the second one. So we basically got file is not equal to null. Now, you don't have to use not equal. I just use not equal because it's a really easy guaranteed way. So we're going to say file 1 is not equal to null. It has content in it. And then file 2 is equal to null. And then so this would then, if this is obviously it has content in it, it will evaluate to be true. This doesn't have content in it, it'll evaluate to be true. And because both values are true, then the condition is met. Now, if I change that to an OR, then only one or the other of the items need to be true. So what it means is, if this is true and that's false, it's still true. So it's going back to those logic gates. So what we're going to do is go back, and we're going to obviously look at the third statement, which is file 1 is equal to null and file 2 is not equal to null. So it's the complete opposite. File 2 has content, file 1 doesn't. Is that a situation there? And it will say yes or no. And then the final one is both files have content. So what we're going to do here is we're just going to quickly smash out some content. So what we're going to do is we're actually going to create some mock data. So what I'm going to do is I'm just going to create a text file. I'm going to call it mock data. So essentially when we run this, we had the first condition, we actually entered the first block. Both of the data didn't exist. So what we're going to do is we're going to say this is mock data, And now if we rerun this piece of code, this condition won't exist. It's going to be the second condition. So we should see second block when we rerun this. So let's do that. So now you can see here we've got the second block being executed because there's mock data right here in the demos directory. We can see that there's mock data. So that's essentially how we can articulate a more complicated else if structure. I'm not going to go into it anymore because I think I've pretty much communicated it, but it's just a really effective way of being able to kind of group your code and make it logically readable. All right, next cell. Final one is else. So else is basically is used to execute code when all other conditions are not met. Now, I'm really tired. So essentially what that is that when you're basically, I've obviously got that stuck in an asterisk. That basically means after an else if. So that's not before an else if, that's after an else if. So else ifs are obviously optional. Most traditional form is if else. That's supposed to be an if. And then you'd have an else. Most of your code's going to look like this. That's how it usually sits. But the thing is, else if actually sits inside here. It's the final stop before, it's the end of the line. It's the station at the end of the line. So that's basically this whole, obviously this kind of approach. So it's a really good idea. It's a really handle to do. Really good when you want to do something. So for example, file doesn't exist. You're going to write a warning. You're going to do some bits and pieces, and you're going to create that file and maybe open it. File already exists. Maybe you're going to rename that file and recreate it. So essentially there's two different pieces, completely different pieces of code that need to go into that. And that's actually a really good example of an if else when you would actually use it. So let's clear our screen again and we're going to the next slide. So I'm going to quickly talk about else, if else and else if recommendations, and then we're going to quickly do a demo. So essentially, it's really used for single condition evaluation and for simple complex condition evaluation. What I mean by that is if you've got more than, let's say 5, I'll say maybe 3 or 4 else ifs, it's probably time to look at a switch statement. Now there is a slight caveat to that, and that's basically you need to be careful on how you're doing your evaluations. If you're doing very complex evaluations with multiple sources, that's something that you need to cater for. Now there is a new feature that was added in C# where you could actually do switch statements on multiple conditions. So I do expect that that's probably going to flow into PowerShell and sometime soon. So essentially, for the time being, it's really going to just be stuck with, it's really, maintaining about 4 else ifs, anything after that, or any sort of complicated ifs, when you have complicated conditions. So that's pretty much that. So let's go back to demos. We're going back to demos. So we've got our else. So else is used when all other conditions are not met. So essentially, we're going to declare our array. Is 6 in the array? This won't get executed, but this will. So if we run that, you can see here this is going to get executed. 6 is not in the array, therefore it'll run this block. The reason why is because the condition here is obviously, like we said, this evaluates to the true. This is going to evaluate to anything else. If any else if or anything else, it will. This is the last stop. And since there's only 2 possible outcomes, this is going to evaluate to be a false. This is true. This is false. Let's use the previous else if example. So one of the things that we did is that if we looked at the previous else if example was we actually just had these 4 else if statements. Now we actually know that these 4 else if statements are actually 1, 2, 3, 4. We can just drop. Sorry, I think I just jumped myself. I jumped ahead of myself. So what I've got in this demo is I'm actually just going to drop an else down the bottom here. And this is actually a really good example of an else. So you have your else if in terms of the structure. You have your else if, then you have your else. This drops right down the bottom. Looks pretty normal. But the thing is, if you think about the code, the logic, that will never ever get executed. Why? Because all the conditions are being satisfied here. So we can actually refactor this code to actually make it better. And so what we can actually do is we can actually make sorry, we don't need that. So what we can do is we can actually do it a better way by removing the last if statement, because we know the final piece of logic, it's if there's only four conditions that can actually occur for the specific action. And because we know the 4 conditions, the final condition, we can be 100% sure that that condition is going to be both files have content. But we don't actually need to test for it. We just need to put an else because we're in control of the data. We're in control of the statements. So essentially, that's the else statements. So what we can do here. So the else statement is the last stop before the end of the line. It's basically it's the be all end all. So when everything else fails, run this piece of code. Now the else statement is really useful for things like when you're doing a whole bunch of error checking and the very last and anything unexpected. We're talking unexpected stuff. It falls in here, so you can raise an error. Hey, why am I getting a 6 when I should be getting, 1 to 5, and I've got a 6 in the array? Something's not right. So that's a really good example of the error. Alrighty. Oh, sorry, the error, the else. Okay. Switch statements. So a switch statement's basically used for checking multiple conditions. So essentially, it's really optimized for being able to actually, if you've got you're checking multiple names, so let's say you've got a list of users, you've got Barry, Larry, Sally, and Tom, and Peter, Joan, and all these other things, and you want to be able to perform different actions, or you've got different colors, you've got red, blue, green, purple, or different shapes, circle, triangle, square, star, things like that. You can do, this is actually an easier way to be able to articulate it. So what we have here is basically we can use the check multiple conditions, and it basically lists, you can list each condition and its optional action. And I use the word optional because it's optional. You don't have to use, it's not something that basically is required. So you don't have to, you can have it there, like the action doesn't need to do anything. You can have it enter, but realistically, you really usually, if you want to do something with that action, you usually do something with that action. So let's say here we've got our switch statement. As you can see, it's declared with a switch, and then we actually place inside a condition our test value. And it just needs to be a test value. There's not really anything special. And then in there, we specify each condition followed by a script block with its action. So let's actually quickly have a look at that. So you can see here we've got our string hello. I'm going to bring that into memory, and we've got switch string. So actually obviously have a condition, and we're just bringing that in. And then initially our condition that we're matching on is hello. So like what I said with a PowerShell, also with the initial condition matching with an if statement, the condition matching is the same. It needs to evaluate to be true. Now you can do the flips and all that kind of stuff. You can flip it to be false, but essentially this, for readability, you're matching on specific, you're just matching on true. It just makes things easier. So if I execute this, I should see, hey, I'm here, as printed to the screen. So I'm just going to quickly clear the screen. We're going to run this, and you can see it's printed, hey, I'm here. And that's essentially your switch. It's pretty straightforward. Now, one of the things that with a switch statement is that basically switch statements will iterate through each condition. Multiple conditions can be met. This is really quite cool because if, let's say, you want to do something, let's say you've got let's say you've got you're matching on people's names, and the first name is Sally. Excuse me. You could have potentially multiple Sallys. Okay, sweet. But then you want to match on their eye color. So there could be multiple Sallys with different eye colors. So you can actually have multiple conditions within the statement being met, and they will do different things. So it's a really very handy thing, but it also catches you out. Now, if you don't want that to happen, and you don't want it to basically, so let's say you have Sally, and you don't want to measure it on eyes or something like that, essentially what you can have is you can use a break statement to terminate the switch. And the break will basically say, I'm going to exit, we're done. Now, there is actually a default clause in the switch statement. And a default clause is essentially an else statement. It's triggered when there's no match. So it's, like I said, it's the last stop before the end of the station. And you can be basically using that to raise errors and things like that. So what we can do is we're going to erase all our ink on the slide, and we're going to jump back into some demos. So if we jump back into our demos here, we can see switch statements will compare other values in the condition. So we can see this by declaring hello again. And we have hello here, and we have hello down here. And so we should actually see it execute saying, hey, I'm here, and what? I'm being executed again, hi there. So if we basically run that, you can see there we've got, hey, I'm here, what? I'm being executed again, well, hi there. So that's essentially you got your switch statement, and you can see it execute multiple times. So it's something that's very important because it might catch you out. Now, when you can actually do regex matching and things like that in this. So basically, there's potential that these conditions can be met multiple times. Now, obviously, we don't want that to happen. Let's say we do not want that to happen. We're going to actually put a break statement in every script block. Now, you don't have to do this, but I'm just doing it to make a point. Essentially, when this statement gets triggered again, which is hello, it'll say, hey, I'm here. It'll run the break statement, and it'll exit the switch. So all these other conditions won't be evaluated. So if we run this, you can see, hey, I'm here. But what we're going to do to actually prove that it's actually iterating through and evaluating, I am going to drop a breakpoint on this, and we're actually going to execute this code. So you can see now the debugger's actually entered the switch statement, and we're actually going to step in. So I'm pressing F11, and we're stepping into the hello. So now it's going to do matching on the string, which is, we know is hello. We can see that in the IntelliSense there, and we're matching on hello there. So you can see it's matched it successfully, and it's now entered the right host. And we're going to see a print, hey, I'm here. As you can see there, now it's matching on the following condition, which is some other string. Is that the same? No, it's not. Is that the same? No, it's not. Is that the same? Yes, it is. So it's actually going to execute again. And you can see it's ended the switch statement, it's brought it back up to the top, and now it will then step onto the next line below it. Now, another thing which is really important, which we'll quickly just show, is that basically the break. So I'm going to rerun the code, and we're now paused on this specific switch statement. So again, does the string hello match the condition? Yes, it does. Right host, hey, I'm here. We can see that it prints down the bottom, and now we're going to call break. Now watch that. It just immediately terminated it. There was no other evaluations. So break can be used to actually exit and exit that. Now that will obviously improve performance, so you're going to get a performance increase, but at the same time you just need to be aware that if you have multiple matchings, that's obviously going to cause issues. The final one we're going to talk about is the default operator. So the default operator is basically when all other conditions are not met. So like an else. So if we run this, we're going to actually, we've got never going to give you up, never going to let you down. So essentially, if we run this code here, we've got string and string. So we obviously enter our switch statement, and we're matching on string. So hello, is that the same? No, it's not. Some other string, is that the same? It's not. Another random string, is that? No. Hello, no. So we're basically testing again. Are they the same? No, it's not. And then it's finally dropped into the default because every other condition was not met. Therefore, it will say, really? A Rickroll? And then obviously fallout. And so you can use that as like a unexpected values. So like whether it's an error or some sort of issue. So that's basically switch statements. So like you can see here, switch condition 3 right host. Here we go again. So we can actually match multiple times. Now, the final thing I want to quickly talk about is the semicolon before we take a quick break into an intermission. But essentially, the semicolon is denoting the end of a statement or a line in PowerShell. It's not required. It's more used for, like, you can see it in JavaScript or C#. But it's useful. It's really useful because you can combine multiple lines into the same line. And the reason why I want to talk about this is we're going to see this in the for statement. People are going to wonder why there's a semicolon there, and this is going to explain it. So essentially, this a semicolon. So if we quickly jump in there, I wonder if I have a demo. I don't think I've put a demo in this. I didn't. So essentially, a demo. So a quick demo would be. I'm just going to create a quick file. -1. I was going to say -1. Demo. So we can have a single line, right host. Actually, I thought I did, but I didn't. We can write host, hello world. Actually, I thought I did. I did write one. Sorry, I thought I didn't, but I did. Move to recycle bin. So here's one here. So we've got get process. We've got our standard two-line statement, or two-line script. We have get process and write host. So if we run those, we're basically printing the 0 index, so the very first item within the array. Actually, it's a collection, and we're obviously specifying the property. But we can actually combine that into a single line by using the semicolon. So we're saying this is a statement, this is a statement. So if we run that again, you can see you have the exact same output. It basically is running this first, and then it will run this second. But essentially, it's just treating it as two lines. So that is semicolons. What we're going to do is have a quick break. We are right on time. We're going to set a timer maybe for, let's say, 9:58. We're going to basically be back at 9:58, and we will be stepping into PowerShell and Looping. So what I'm going to do is I'm just going to check some music back on. And we're just going to drop in some NCS. And we will be back. And I'm just going to quickly put the AFK screen on. So I'll see you guys back. 5 minutes, stand up, stretch your legs, and we'll be back, and we will continue on with the keynote. All right, we'll see you then.
like something more than a closed door flat on the floor. I can offer so much more. All I ever wanted was to feel at ease. All I ever needed was to get up off my feet. 'Cause I believe in more. Hold on just a little. We'll meet right here in the middle ground is where we'll stand. Let go of the brittle, 'cause you'll find life is a riddle that we're not meant to understand.
I'm not gonna lie to you kids, it's a fucking jungle out there. Keep your head on tight, unknown brain and mind me, baby, let's do it. Y'all see me flying, never drop down, smoking high, I am not round, I'm not round, no denying what I got now, keep an eye out, keep it locked down, see me flying, never drop down, smoking high, I am not round, I'm not round, no denying what I got now, keep an eye out, keep it locked down, get too strong when I battle with the beast, bring a few on, the commander and the chief for my crew on, bullets rattling and whistle at your toque, never sleep, eyes open, hands clutching on my loop, this a war zone. It's a war zone. Yo, this a motherfucking war zone. It's a war zone.
Okay, now you can hear me. Oh, don't tell me it was muted. I don't think it was muted the whole time. I hope it wasn't, because that's going to be a pain. Let me check. I don't think it was. Well, oh well. If it is, it is. Here's what it is. Alrighty. We're back. PowerShell looping. I do have mangoes with me, so I'm going to be eating some mangoes. So forgive all the noises. So PowerShell and looping. Now we're back. Essentially, PowerShell. We're going to be discussing PowerShell looping, different types of PowerShell loops. So what we have here is we have our quick bit of a looping introduction to you guys. So essentially, looping is a process that allows you to a program to recursively iterate through a set of items. Now that's basically when I use the word items, I'm really talking about it can be anything. It's a recursive thing. It doesn't have to be items. It can be, you can loop for various reasons, but essentially it's usually for items or something, those kinds of things. But essentially you can loop for times. So if you know the time hasn't been met, things like that, then you could say I want to loop. But essentially it can be for files, it can be for words, it could be for URLs, like I said, time. It could be for literally anything that you want it to, the code to repeat until a condition is met. Now, looping removes the constraints by allowing for repeatable code. So essentially, you don't have to have double ups of code. You can basically write your code to be a lot more robust. So in PowerShell, there's a couple of statements that we have. We've got the do loop, we've got the while loop, we've got the for loop, we've got the for each loop, and then we've got the for each object loop. So we've got 5 of them. Now we're going to be looking at them all, and we're going to basically be predominantly focusing on, actually we're going to be looking at them all equally, and we're going to be looking at some fun little shenanigans as well. So let's get stuck into it. So we're going to be talking about the do while loop. Actually, give me one moment. I'm going to go get a knife, and I'm going to get a spoon so I can eat some mangoes. One moment. I'm just going to mute that. All right. We're back. Okay, so essentially, the do while statement, you got do, until, and while. So the do statement basically is we're going to enter the loop and execute some code. Now the condition is evaluated at the end of the do loop, and the condition can be either a while or an until, or sorry, until or while. So we have our executable code here. We're doing something inside of here. And then basically at the end, we have an until or a while. And that basically determines how the condition is to be processed. Now, an until condition, so when we have an until and condition, it'll continue to loop until the condition is met, which sounds it sounds exactly what it says. But essentially what we're thinking about here is when we have an until the condition is met, we're thinking about this is basically evaluating. It'll continue. It always muddles me up because of the way that you have to articulate the process. Articulate this. Essentially, the until is naturally evaluating to be false. Is it false? Oh, sorry, no. It's actually, sorry, no. It's naturally evaluating to be true. So it'll continue to loop until it equals to be true. So it naturally evaluates to be true. The while statement is the opposite. So the while statement says, I will continue to loop while the condition is not met. So what we can say here is it's false. Is not met. So you could say, do while the file doesn't exist. Keep looping. That's a really good example. Keep looping while the file doesn't exist. The file doesn't exist, but once that condition is met, then obviously it will exit the loop. So that is a really good example of the two differences between a do and a while. Oh, sorry, an until and a while. An until naturally evaluates to be true until the condition is met, while a while is while the condition hasn't been met or is not met. So is met, is not met. Let's go to the next slide. So now we've got do, until, while. Oh, we've obviously got some different kind of use cases here. The do is always best used on a loop on non-array events. So what I mean by that is if you're using an array of items, there's a better do there's a better looping mechanism versus using a do. Now there are certain circumstances you might need to use a do, but essentially you shouldn't, because there's simpler code to be able to actually, there's other looping mechanisms to be able to actually achieve that outcome more efficiently and effectively and with more maintainable code. So essentially here we have our first iteration of the loop will always be executed. So what that basically means is if we have a do and we've got our thing, the condition is down the bottom, which means this code in here will always be executed first. So if we jump into a demo, this is obviously a very simple example of a demo. So what we're going to do is we've got a val is equal to true. Obviously, until val is equal to true, it's naturally evaluating to be true until the condition is met. And what we're going to say here is we're just going to put a breakpoint there, and we're going to put a breakpoint. Actually, we're going to put a breakpoint right on the do. We're going to put a breakpoint on line 7. And we're actually going to see this so everyone can see this. So essentially, let's run this code. So I'm going to press F5. Okay, that didn't work. I'm just going to try and didn't actually register that breakpoint for some reason. Might need to put a breakpoint there. So let's try this. Okay, sweet. So now we've actually put a breakpoint in this. So what we're going to do is we can see we've set a variable called val, and we set it to as a Boolean operator to true. As you can see, the first thing we did was we actually have gone into the loop. We're now in the executable code for the loop, and we're now running start sleep. So basically sleep for 5 seconds. 1, 2, 3, 4, 5. Wait for my back. Here we go. And now it's validating the condition. So is vals true? Yes, it is, because until is naturally will naturally evaluate, or will evaluate to be true. We can then exit, and that's basically how a do loop works. You can see it will always evaluate the condition at the end of the loop versus the beginning of the loop. Straightforward. So like I said, at the end of the loop, and it always will be executed no matter what. Now so what we're going to do now is we're going to talk about, I think it's the while loop. That's a little different. Sorry, I'm just trying to get some mango. Okay. So the while loop. Oh no, we actually have some examples of until and while. Cool. I was thinking about it. So essentially, we have do, until, while, and examples. So this is a really good example. We've got the condition is met and the condition is not met. So this will continue to loop until the condition is met. So if you have something here, for example, you will continue to sleep until the file exists. So that's a really good example of an until. A while would be keep looping while the file doesn't exist. So it's the complete opposite, while the condition is not being met. So that's a really good example of the differences between an until and a while. All right, now we're going to look at a while statement. So a while statement's basically you execute a while condition is met. So essentially, a while statement executes the condition at the top of the loop versus a do executes it down the bottom. So a while statement basically will execute. Obviously, you can see here we got a while, then we have a condition, and then we have our code. So do's and whiles have their both of their uses. I'm going to quickly show a demo of do and while. So you can see here, this is a basic, again, super basic. I'm going to drop a breakpoint. We're going to actually step through this. So in this example, this code won't be executed because the condition evaluates to be true. And this is really useful for those kinds of situations where you might have, you want to match the condition before executing a code. There's a chance that that outcome might be true from initially before executing the code. So you might actually save some, compute. So in this instance, we have var is equal to true. We're obviously going to while var. So obviously while the condition var is true. Yeah, so while the condition var is true, actually this might actually enter the code. It is going to enter the code. I made that incorrect. So what I'm going to say is while it's not true, I thought about that for a second, and I realized that was not right. So while the statement doesn't exist in this instance, so if this was false, then it will execute this code. So if we rerun this, so it basically says while this is true, which we know it's true, and then we're going to use the not, and we're going to flip it. And so now we've got the not, and this should flip to false. I just hit F11, and it actually finished the code. That's the reason why. So I'm actually going to put something down here. So we can see this run. So I'm just going to quickly remove the breakpoint, and you can see here end of script. So essentially, it's evaluated it. No, this condition's already met. We don't need to execute this code. Okay, go to the end of the script. So that's essentially a while. Use cases. So use cases are always fun because there are always different types of use cases for different things. And in this instance, I'm going to quickly take you through two different use cases. So the scenario is we're waiting for a file to be created. So essentially, there's two ways we can write this. We can write it with a do statement and let's say we're just going to use a do until, and then we're going to use a while statement down the bottom here. So essentially, the scenario is we're waiting for a file to be created. So the first loop will basically be we'll pause the execution of the script, then test the file exists. The second loop will test if the file exists, and then if it doesn't, pause the script execution. So this is actually a really good example of two different types of ways you can structure your code. Now in this instance, it actually is more efficient since the file could potentially exist already, and it makes better sense to use a while statement, because if the file already exists, we don't actually want to pause our code execution for a second. And the second reason why this is really, really important, because there's a chance that the file already exists, that basically our code is actually going to perform obviously more optimally. So obviously it's going to sleep for a second and then it's going to test for the condition. But essentially this sleep is going to stop our execution. So that's basically a kind of a use case in terms of two different ways you can basically have for a do or a while statement. Now let's consider let's consider another use case. So we basically have, here, we're trying to read a file. So now for some reason, the file access is intermittent. We don't know why, but the file access is intermittent. I'm just going to draw a line between the two down the bottom there so we can see that this is one and this is another. So essentially here, we're going to read some data, and we're going to basically load it into memory. We're going to declare a variable here, and then we're going to basically check, and we're going to basically try and read it until the data is not null. So we're going to basically, until there's something in that file, there's some sort of data inside that file. The second one is we're actually going to see if it's null, and then we're going to try and read the data. Now this is, so these are two completely different approaches. Now in this instance, the first loop is actually better because the file data could be set somewhere else in the code. So this variable, so you can see here, this variable is evaluating on something. Now we're assuming that all this code up here, they're two separate scenarios. If this variable is set somewhere else, that's introducing a potential bug into your code. The second thing is that basically we need to read the data, and because we need to read the data, it's more effective to read the data than to check. Because at the end of the day though, we haven't read the data. The first action that we need to do is read the data within the loop. So it makes better sense to basically, we know the data doesn't exist, therefore read the data. So this is a whole optimistic, pessimistic approach. In this instance, we know that the data might not exist, so we're going to be pessimistic about it, and we're basically just going to try and load the data in. Once the data is loaded, or potentially loaded, we're going to test if it actually has been loaded by basically saying until file data is not equal to null. So it's going to keep smashing that disk, trying to read that file until something gets added to it. Now the second thing here is we've got basically within the while statement, we're saying, well, is the file data equal to null? Well, yes it is. Or it might potentially not. So you're already evaluating, we kind of know it doesn't exist. We're already assuming that it doesn't exist. We're being pessimistic. So in that instance, basically we're going to try and read the data, and then we're going to evaluate. Now in this instance, this will actually evaluate the condition twice, and in this instance, it'll evaluate it once. So this instance is actually, in somewhat, will be faster and easier. Now this instance is easier to understand because the file data needs to be loaded. So essentially we're going to load the file data, and then we're going to basically test if it exists, versus does the file data exist? Well, we know it doesn't exist, so then enter the loop. So these are two really good examples of a do and a while, and when to use an actual do loop. Alrighty, so one of the things that I quickly want to just check is, do I have any demos for that? I don't think I did. That's fine. Perfect. So let's go into the next slide. For each. So for each is basically used to iterate through an item within an array. Now that can be or a property or an object within a collection. So essentially, the definition is you have a for each item in an array, which sounds pretty straightforward. But we're actually, it can get quite complicated to understand. So what we're going to quickly do here is, I'm just going to quickly grab another paper towel because I've got mango on my hands. So essentially, we have our statement here. We have a for each, and then we have a variable. Now this variable holds the current item within the array. So this is basically, and what we call an idisposable. Oh, I think, is it an idisposable? I think it is an idisposable. Yeah, I think it is an idisposable. And basically what it means is that it's just the current item within the array. So if you're looping through an array, it'd be the value 1 in the first loop, value 2 in the second loop, value 3 in the third loop. And then we'd have a script block. And the script block would basically, you do something with it. Now you need to, if you want to access that specific object or value item within the array or collection, you need to use the item variable. That's why it exists. Now one thing that's important is that it actually persists outside the loop, and we're going to actually show you that in a demo. The second thing is we have an array. The array is basically the array of objects that you pass into it. So this would be something where you do get processes, and then you'd store that in a variable, and that would get passed into this. And then finally we have our script block code, which is just code to execute. And that's pretty straightforward. So what we're going to do is we're going to erase all that ink on a slide, we're going to Alt-Tab, and we're going to go do a demo. So this is a really good example of for each. So we're fetching all our processes, and we're using for each to iterate through each of the items within the array. So we've got the variable process declared, and which is declared for this loop, and we've basically got process is our array that we're passing from line 5 into line 8. So what we're going to do is we're going to basically, in here, our code is basically going to print out the process name by addressing the process variable, and in this instance it's an object because we're basically using the processes, the PS process object, and we're basically passing that, we're specifying the property name and ID, and we're just printing that to a string. So we're just going to go ahead and run this, and you can see that we're printing out each of the process names, I'm printing out the process ID, and then I'm saying meow on the end. Now one of the things that we also need to note is that basically the process exists after the loop. So if I run this, you can see that the very last, the object that was at the end of the array, or the collection, your phone is actually exists outside the loop. This variable still exists. That's a gotcha, but it's and it's something that you need to be aware of. So that's basically a for each. For, let's get into for. So for basically runs a command block based on a conditional test. That sounds like a biggest load of gobbledygook. That was basically what the internet said. It makes sense if you understand it, so I'm going to kind of try and break this down for you. So essentially, it is a it's a really good way of self-contained way of being able to actually run code prior to execution, test the condition, and then basically run code after the command has been completed. So essentially, we have our initialization. So initialization initializes your variables. Now they're separated by commas when the block starts. Then we define our condition. So a condition that evaluates to be true, so is equal to 5. It will then terminate the loop, and it will exit the loop. And then finally we have our repeat. And the repeats basically, these are the commands that we want to run when the loop repeats. So what I'm going to quickly do, actually I have to go quickly to the gents for a moment. I will step back in 2 seconds. All right, I'm back. Okay, so For. So let's have a quick look at an example. So we have our for statement. We've got for I is equal to 0, I is less than 10, and then we have an I++. Now, one of the things you can notice is that it's denoted by a semicolon. So remember how we earlier in this chat, we basically in this lesson, we were talking about semicolon denotes the end of a statement. This is the equivalent of that. It's basically this is a statement, this is a statement, this is a statement. So that's basically most of the time people kind of look at this and go, well, you know, you have to follow this, but they don't fully understand why that these semicolons are here, and it's denoting this is the initialization, this is the condition, this is basically the repeat, and then we're obviously doing something. So obviously in this instance, I is equal to 0. This is our initialization. We're creating the variable I, and we're setting it to be 0. I is greater than 10. So the condition is I is greater than 10. So what we remember is we're naturally evaluating to be true. Once the condition is met, the for statement will exit. And then at the very end here we have, the end, which is actually not the end, it's called the repeat. I'm actually going to quickly change that now. Discard. Like so. So we have the repeat, and the repeat's basically exactly what it says it is. So it's the commands that we need to run when the loop repeats. Oh, no, that doesn't work. When the loop repeats. So essentially, these are the bits and pieces we need to do to basically when the code repeats. Now this is really quite handy because we can do cool things with it. So essentially, let's have a quick look at an example. So we have a for here, and we've said I is equal to 0, I is less than 10, I++. Actually, I think this is a, I think this is a, actually, sorry, no, it is. I just kind of went back one slide. Obviously, yes, we're repeating. So that's our example. So obviously, there's our initialization. I is equal to 0. I is greater than 10. This is our condition. It's naturally evaluating to be true. Once it evaluates to be true, it will end the loop. And then finally, the repeat. So I++ basically says add 1 to I. That's what it says. Now, we're going to have a quick look at a demo. Let's jump into demo land. So what we got in here is we've got some bits and pieces that we've playing around with. So I'm just kind of, while I'm doing that, I'm going to carve up a bit of a mango. So let's count to 10. So this is a really basic for statement, but it's a really good example to count to 10. So we've declared I to be 0. I'm just actually just making sure that my logic's right. I think I've stuffed it up. I think I've stuffed up the for statement. It's not. Sorry. Sorry. No, it is evaluating to be true. So essentially, not equal to 10. I to be 0. Condition. I is not equal to 10. And add 1 to I. Cool. So basically here we're saying I is not equal to 10. Add 1. So our initialization, we're declaring the variable. There's our condition. There's our repeat. So it'll step in. We're actually going to do this. We're actually going to put a breakpoint there. We're going to step in. So we're going to declare the initialization. Well, we actually did it. Now we're declaring the condition, and that's going in. is I, and then it's going to basically run the repeat. You can see it's on this right hand side. It's actually incrementing 1 to I, and now it's actually rechecking the condition. Is I not equal to 10? Yes, it is. It's naturally evaluating to be true. Yeah, okay. So I just realized I made a bit of a boo-boo. So the loop will enter when the condition is met. When the condition is not met, the loop will exit. So obviously I is not equal to 10. The loop will the condition is met. So if we say this, if I just if we say I is, damn it, I'm just going to put a breakpoint here. If we say I is not equal to 10, it's true. The condition is being met. Enter the loop. So essentially, it's just a while statement. So once it evaluates to be true, then enter the loop. If it once it stops being true and evaluates to be false, exit the loop. So yeah. Sorry, I'm just quickly eating some mango. Okay, so essentially here, that's basically it in terms of a while statement. So I'm just going to quickly clear the screen. So when we're talking about the initialization, condition, and repeat, it's easier to represent it this way. I'll say it's easy to represent. It's easy to visualize it. So you have 3 lines here. So we've just done the same thing. It's the exact same process. So if we just F11 is not equal to 10. F8. So you can see here we've got 0 to 9. So it's just counting 0 to 9. It's exactly the same as this. 0 to 9. The only difference between this and this is just breaking it out. This has semicolons and this doesn't. So basically I'm just breaking out each of those statements. So the initialize, the condition, and basically the repeat. Post process, I'm just going to call it repeat. Prior to obviously this one, you're just declaring it all on one line. Now we can count. That's pretty cool. Well, let's count back from 10 by using I minus minus. So what we're going to say here is we're going to say I is equal to 10. So we're setting the I variable to 10. We're saying is continue to loop until I is not equal to 0. Oh, sorry, yeah. Continue to loop while I is not equal to 0 and subtract 1 from I. So if we run this, you can see it counts from 10 to 1. Now, that's pretty cool, but you can do other things. We can count in 2s. So you can see here I'm just saying I equals I plus 2, so it's actually adding 2. That's another way we can do it. Now you could hypothetically do it this way. I actually haven't tested it, so we're going to actually try this way. It's going to be very interesting. And we're going to use a comma. So we're going to try this. This should actually work as well. That should count in 2s. Yep, 0, 2, 4, 6, 8. And we're basically using the we're using the comma to denote the different things, or the different what's the exact term? So yeah, the variables that we want to basically adjust when the repeats runs. So you can see here you just double I's. Now that's all right. Now another thing we can do is we can actually use we can actually do other things with a for loop. So essentially we're doing the same count. So we're saying I is equal to 0. But what we're doing here is we're actually using processes. And so we're getting the process, and then basically we're getting the count of that process, or we're getting the count of all the items within that process. So I've just run process and pulled it in memory, and we can actually have a look at this. And you can see here we've got 271 processes. That's what the processes.count says. That's the property count. And what we're going to do is we're going to iterate through that. But what we're going to do, well, this is a different way of doing it, but essentially there's many ways to do it, but this is just another way of doing it. We're going to print the name property by indexing through the array. So we're going to call the collection, so this is our collection here. We're going to pass the I integer as an index into that collection, and we're going to call the property name. So remember how when you have a square bracket after an array, let's say array, and you specify an index item, that is that you would go and get the value of that index item from the array or from the collection. So in this instance, we're getting the value that's defined by the count, so it'll just basically count through each of them and then fetch the property name. So if we run this, we'll see all the property names get printed out, and that's really a good example of we're actually using a for loop to actually index into an array. Not the best way, because obviously for each is a better use for it, and for each object, but essentially it's still there for use. Okay, so that's basically the for. So let's jump back into the PowerPoint and let's go and have a look. For example, the break, the continue, and the return. So I'm kind of taking a quick stop. We're kind of taking a quick detour before we do for each object. So we're going to have a look at this, and we're going to look at loop labels. But essentially, this is really important to kind of articulate before going there. So basically what these statements do is they actually either suspend stop the execution of the loop condition, either return to the top of the loop and skip the current iteration of that loop, or within it, for example, with return for each object, it'll return to the next item. So that's sounds already confusing, and there's an asterisk here, and every time you see an asterisk, you know there's something's up and there's shenanigans going on. With PowerShell, there's shenanigans going on. For each object behaves differently to every other looping mechanism, and we're going to look at that very last. That's going to be the very last demo, which is the shenanigans demo. But essentially, we're going to be focusing in this specific slide. We're just going to be looking at for each, do, while. Those loops have the will operate as normal. For each object, it has weirdness. So essentially, with any of the normal looping, with the exception of for each, so you can pretty much just think of any normal loop with the exception to for each, operates with a break and a continue. So the break basically exits the loop, where the continue returns to the top of the loop. So that's really good. So for example, you've hit a specific name for some reason in your loop and you want to exit the loop, you can just go break, and you'll break out of the loop. So it'll obviously prevent that it'll save compute, and obviously get you can get better results. Continue, let's say it doesn't match a specific user, and you've got a list of users within Active Directory. You can basically just say continue, and that will basically then skip that specific item within the loop, and then iteration, and then go to the top of the loop. Now there's an asterisk there, and the reason why the asterisk there again is because of for each object. This behaves completely differently, very, very differently to what you would expect, and it's something that I actually went into a bit of a demo because I do think it's something that's worth actually exploring. So we're going to have a quick look at the demo at the normal stuff. We're not going to look at the shenanigans at the moment. That's going to be the very last demo. So what we're going to do here is we're just going to jump into break and continue. So as you can see in here, we're going to basically demo a break statement. So when the counter equals 5, we're going to break out of the loop, even though the loop should exit at 10. So you can see here that basically the condition is to equal 10, but we're not going to do that. We're going to break out at 5. So if we go ahead and run this, we're actually going to we're going to put a breakpoint there so we actually can see it hit this point. And we're going to actually see the counter by it printing to the screen. So what we're going to do is we're going to hit that, and you can see 1, 2, 3, 4, 5, and now it's going to hit the break. Now, one of the things that's really important is that obviously you're like, it's quite slow. The reason why is because it's actually sleeping. So now it's going to hit the break. We know the counter, we can actually just put pull counter. We know counter's at 5. We're going to exit. So what we're going to do is we're going to use the break. So if we use break now, you can see it immediately exited the loop. Now I'm going to show that again. We're just going to comment that line out, and we can actually see it run to 10 now. Let's just rerun this. So we're going to see it count to 10. So 4, 5, 6, 7, 8, 9, 10. So essentially, that break exited the loop once the counter equaled 5. Now we can actually see that. So if we actually run this line here, we can see the output counter, which is 10. But if we rerun this again, we're going to see the output counter to be 5. So let's go ahead and do that. So it's hit 5, and then we're going to see this is the output 5. So essentially, it's hit this line, it's broken the loop, and now it's then progressed onto line 18 there. So the next thing is we're going to demo a continue statement. So this is a really basic demo. We've basically got some code here. We've got a counter, and we're going to run the continue statement exit. I don't know why. I literally wrote this at 10 o'clock last night, so I was sitting waiting for a plane and I was incredibly tired. We're going to run the continue statement, skipping the current iteration of the loop. Now what's really interesting is that basically we have some extra code after this. So what I'm going to do is I'm going to quickly comment this out so we can just see it normally execute. And you can see 1, 2, 3, or 1, 2, 3, 4, 5. I need to redeclare the counter. I'm just going to set the counter back to 0. So if we rerun this, you can see it ran 10 times. Sweet. So let's actually use the continue statement. Now, one of the things I'm going to quickly run it again. There was one thing I actually needed to illustrate. So you can see here, there was 2 blocks. There was 2 write lines. We had I am some code, and then we had down here, this code won't run. So that's pretty straightforward. But now if I put a continue statement here, and we're actually going to put a breakpoint on this so we can actually see the execution. Once we actually see it go, I'm actually just going to quickly comment all this out. Thank you. I'm just going to comment all that code out so that we don't have to execute it again. So we're just going to run this code. And you can see here we've hit the continue statement, and we see that it's printed I am some code. Okay, sweet. Now if we watch the continue statement and we execute this, it's immediately returned back to the condition evaluation. So essentially this code will never ever get run. And so if we remove the breakpoint, we'll only see I am some code because the continue statement is actually skipping that current iteration of the loop. Very useful. So I'm just going to remove this code because we just need to, obviously, for the demos. But that's a really good example of the break and continue statement. We're going to come back to return. There's a lot of shenanigans going on there. One of the things that basically was introduced in PowerShell 6 was loop labels. So what loop labels is you can actually define a label on a loop. It's really used for loop nesting. So when you have a loop inside a loop or loopception, you can and the reason why is what you can do with it, you can actually break loops in different areas. So what I mean by that is, let's say you've got a loop here, and then you have a loop in here, and let's say you want to continue here. Let's say you've got the continue statement here. That continue statement before PowerShell 6 would only apply to this loop. It won't apply to the parent loop. But let's say you wanted to actually break, or you wanted to continue on the iteration of the parent loop. Well, this is where loop labels come in. And what loop labels can do for you is you can actually specify the label, and it will actually go to that specific instance. So the way that the definition works is you define your label. The label can be anything, but essentially it's separated then by a colon, and then your loop. Or it obviously also applies to while, it also applies to for. Now that's really quite cool. And if you want to call it, the way you call it, let's say we've got, in this example, we've got the parent, so it's just parent, and we have a child. If we wanted to exit the parent loop, all we need to do is say break, and then specify the label to break it, that specific label. So when we do that, it'll exit the parent loop versus the exiting the child loop. And that's really quite cool. So we're going to actually quickly demo this. I actually haven't tested this, and this is a PowerShell 6 feature, so we are going to see if this is going to play ball. So, but before we do that, we're just going to step through the code. We're going to have a quick look at the code. So, in this example, we're going to demonstrate how child loop can exit a parent loop. We're going to see the script enter the parent loop. We're going to see the script enter the child process loop. The loop will process 5 times. I'm actually just going to get rid of that. That does make sense. The loop will process 5 times, and we're going to see it count to 5. Once it reaches 5, it's going to exit the parent loop. So there's our parent label, and there's our child label. So essentially, you can see here we've got a counter that's declared in both. Now the counter's nested inside the parent label, and the reason why is because if you didn't do this, from an architecture point of view, this child label would only be executed once. Now in this context, we actually are going to be exiting to the parent, but this is just for programming practices. This is what you would do. You would actually declare it within the loop. So essentially, the counter should go to 10, but we're actually going to see it not. And first things first, we're actually going to put we're going to comment that out so we can actually see the full execution. So we should see I'm in the parent loop. We're going to see that execute 10 times, and then we're going to see this execute 10 times for each iteration of this loop. So that means it should execute 100 times. So let's go and jump into my PowerShell console, wherever I have it. Where's my Win console? I think I've removed it. I think I did. That's fine. Oh, no, I haven't. There, it's right here. Perfect. So what we're going to do is we're going to just browse to this. I haven't actually configured actually, I could probably just do that right now. I'm going to do that right now. I'm actually just going to reconfigure this. Give me 2 seconds. I'm going to reconfigure my PowerShell for Visual Studio Code. PowerShell, where's PowerShell? There it is. Copy as path. I'm just going to search PowerShell. So if we rerun this, PS version table, I have 7. So I'm running PowerShell 7 Preview 4. Now we can get into the good stuff. So what we're going to do here is we're just going to run it and see what happens. We should see a lot of code execution right now. We don't. The term parent label is not recognized. Okay, is this the integrated? Oops. I think it's because I'm running. The term parent label is not recognized as a commandlet script. Did I actually do that right? I'm pretty sure I did. It's going to wrap it inside a string of that. Is that a PowerShell 6 feature? That's weird. I know loop labels works. Now I've actually got to go suss it out because I never tested it. And this is one of the things, if you don't test your demos, PowerShell loop label. I'm just going to seeing if it was actually introduced in PowerShell 7. It might have not been. That's probably the reason why. But I don't know. I think it also might be the fact that I got it wrong. PowerShell loop label. Just quickly Googling it. Yeah, that's fine. That's fine. That's fine. Another loop. Ah, okay, okay, okay. I think I've done it wrong. I think I've done it wrong. Give me 2 seconds. So I think. Okay, so you declare it by semicolon. I thought it was the other way around. I'm just gonna have to go to the slide deck because I know that I was reading the documentation and I thought it was the other way around. Let's have a quick look. Is that about break? Oh, this should be it. Let's have a quick look. Ah, I stuffed it up. My bad. So essentially, you define the label by using simply like a command, a batch goto. So let me quickly fix my actual logic, and it goes like this. And also, I just want to make sure that's right. Yep. Okay. Perfect. So I'm just going to do it like this. So fix that up because that's always good, and then we can basically change it. So essentially, it's like a command prompt go-to method. If you think back in the days of batch scripting. So you got your parent, your child. So let's now jump back into VS Code and fix our code because this is what happens when you don't demo. And we should be able to run it now. So before we do it, I just need to quickly check to make sure my break is correct. So break, yes. So we just specify the label. So yes, perfect. All right. So essentially, what we can do now is if we jump back in here and we rerun our code, we can see all the executions. So that'll be one. You can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it actually exit on 10, so 9. So essentially, there's our labels. So we've got our labels. But let's change that up. So let's actually break to the parent. That's really quite cool. Let's break to the parent. So let's do this again. What we should actually see, and I'm going to drop a breakpoint on this because I think that's actually quite cool. Now remember, this is PowerShell 6 and up. So you need to be running PowerShell core. Just need to clarify. So we can see now we've hit the break parent label. So if we hit F11, it's broken and it's actually terminated the script. Now, I actually want to just quickly put something here so we can see it terminate. Yep, terminate out of the loop. So let's rerun this again, and we should see it actually go to line 34. And there we go. And so that's actually really cool because it means you can then break out of your parent, and you don't have to write complicated code to be able to manage that. So traditionally, if you needed to do that, you'd basically have to set some sort of flag, and that flag would then need to be checked outside of the loop after the until. So you'd do it down here somewhere. But that's basically loop labels, which is really, really cool. And obviously, I got to demo it and get it working, and I thought I had it right, but I didn't. So now we're going to for each object. For each object is similar to for each. Oops, let's drop some mango. Now, I wanted to kind of talk about this because now for each object, actually I'm just going to quickly resume it on the slide. So for each object is similar to for each. It's not the same. It behaves like a for each, but it's not the same. If you have a bit of an understanding of functions in PowerShell and the begin and process and end statements, it makes a little bit more sense. But this course, I would assume that you don't, because obviously we're just targeting 101. This is basic. So essentially, it behaves similarly. It's not the same. And the way that for each object differs from all the others is that it's really used in the PowerShell pipeline. It's one of those commandlets that you can just bash out and quickly do something in it and write some quick code and then pipe it back and push it back into the pipeline. Its really intended use is for the PowerShell pipeline. Now, it has a very average performance. It's not the same as it is recommended in code to use for each versus for each object. However, if you're just bashing something up, then you kind of just use for each object. In terms of non-production stuff, just use for each object. Now, one of the other little caveats is that for each object in PowerShell 7 is being introduced. I think was it 7 or 6? It might be 7. I have to check now. I actually have to check. If we jump back in here, just let me go get sorry, I'm just going to be doing here. It might be 6. Okay, I think it's 6. But one of the features that was introduced in 6 was the fact that it actually could use parallel. So parallel is one of these things in PowerShell that a lot of people talk about, some people might not talk about, but essentially parallel is it's an asynchronous kind of approach to programming where you can have multiple for eaches running, and then basically similarly you could have multiple different, you could be processing multiple things at the same time. That improves performance. But at the same time though, it's similar to for each. They have their intended use. PowerShell pipeline is for each object. For each is an actual looping. Now, one of the things it has is it has really cool features. So it has what we call a begin and a process and end block. And so one of the things that it does is that basically you can declare before the process starts, similar to a for statement. You'd have a variable declaration to set up the on the initialization. You would have a condition, and then you would have a repeat. In this instance, you have a initialization as a begin. You'd have your process block, which is for each item within your object, also within your collection or your array that would get processed. And then you have your end block, and your end block basically is your disposal. So you'd basically be disposing your objects, or you want to pass collections, things like that. You just want to do a bit of a tidy up. So it kind of encompasses all that code, makes it a little bit easier to understand when you if you choose to use it within scripting. Oh, thanks, mate. I really appreciate it, dude. So one of the things that's really quite cool is that you obviously have loop control behavior is different. This is, like I said when I was talking about the break, the return, this is what I'm talking about. It behaves completely differently, and this is something that is really important to understand when you're using for each object. For each object is not for each. It's actually and it makes sense when we actually look at loop control behavior, and the reason why they're similar but they're different. Remember, for each object operates like a commandlet. Well, it is a commandlet, where for each is a statement. The statement basically is literal. It basically, you have your initialization, you have your condition, you have your repeat, where for each object operates like a function or a commandlet. You have a begin, process, and end block. And there's basically your key. That is your key reason why shenanigans happen. So you need to articulate that they're two completely separate things. Now, one of the cool things is that you can access the pipeline object similar to where object by using the $_. So if you want to access the current object within the collection, or the current item within the array, you just can use a $_. And ultimately, it has the alias of a percentile. That's its alias. So now let's quickly jump into some demos. So what we're going to do, I just actually want to quickly check the next slide. No, I'm going to quickly show an example. So this is a basic example. So we've got our collection. You can pipe it to for each object, and then we specify a script block, which is obviously just executable code. We've got our current object. We've declared a variable called var, and we're actually capturing the current object within the pipeline. And then we're just going to do something with this. So previously what I was saying were basically with write output. This is the equivalent of a write output. I'm not explicitly saying it's a write output, but because property is actually going to have a value, it's exactly the same. If it returns something, it's basically going to be treated as a write output. So what we're going to do is we're going to quickly jump into some demos. So obviously, let's have a quick look at for each object. So we just got get processes here, and what we're going to do is we're going to go into the for each object, and this is just the standard the default definition, and we're going to basically just specify our script block, and we're going to just reference the current item by using $_, and we're going to get the property name called name. So this is going to return all the processes name, and we're just returning it via write host. So let's just go ahead and run that, and you can see there we got all our different processes, SVC host, all that kind of stuff. And that's basically a really a rudimentary example of for each object. So let's go ahead and erase all the ink on the slides, and let's go ahead and look at our begin, our process, and our end blocks. So this is a basic structure. You can see here they are parameters. That's the biggest thing. These are parameters. So you have your begin block. So this is where you set up your loop. It's only executed once. You then have your process block. Now the process block is used to actually execute for each of the items within the array. So, or within each object within the collection. So this is basically where your logic will sit. Now, if we go back to the previous code, this is just a process block. So by default, the default execution is just a process block. So you don't have to worry about the for each shenanigans. You don't have to specify it because by default the parameter process is this. So there's no real concern. And then finally you have your end block, and this is obviously where you do your dispose and your return. So you basically just execute it once. That's pretty much it. And this would be executed prior to actually returning to the pipeline. So this is actually prior to returning to the pipeline. So, before we go, now we're going to have a quick look at the begin process and end block. So here we've got that same kind of process. We've got the same demo, except we've just kind of expanded it on a little bit. So instead of just printing out the name to write host, we're actually going to create a collection. And this is really quite cool. So what we've got here is we're going to create we're actually running the command like get process, and we're just declaring a variable called processes, and we're sticking it inside of that. And then we're actually piping processes to for each object. Now in the begin parameter here, we're actually declaring a collection. And this collection is similar to like a for statement. We're just declaring something in memory. So let's pop that. We're actually going to actually can't run that because we're going to run the whole line. But essentially what we're going to do is we're then going to now look at the process block. Now the process block basically iterates through each of the items within the array or the collection. So you can see here what we're going to do is we're going to create a PS custom object using a hash table. I'm just going to basically take a shortcut here, and we're going to set a property name called random property name, and we're going to set the name property to that. And then we're going to create a random property. We're going to create a property called random ID name, and we're going to set the ID to that. And then we're going to add it to this collection that we've declared here. Now you don't have to do this. Like ultimately you can actually put this line outside of this. It's still going to work. It's just that the reason why you do this kind of thing is that it helps articulate the scope of your logic. So essentially, if you know that it's in here, it belongs to this specific piece of logic. It doesn't belong to the parent. So that's really the intention here. And then finally we have the end, and then obviously we're doing disposal. So if we were connecting to an SQL server or something like that, maybe in our begin block here, we would actually set up the whether we import DBA tools or we actually connect to the SQL client in .NET. That's all will be set up in there. The actual query would be run in here. So the initial query for select for this person, and then at the very end we would dispose of the SQL object, and that So that's basically as a comparative example. So in this example, all we're doing is we're actually just writing the output. So this we're going to get run once. So what it's going to do is print out the everything that was added to this array or slash collection. So if we run this, we can actually see it's just dumped it all out, and we can see we've got our random property name and our random ID name. And that's essentially your begin, your process, and your end blocks. Now we get to the shenanigans. This is the very last demo, but it's probably the most important demo for each object. We're going to be looking at the break, the return, and the continue. So this is something that it's really, really important to remember. Like I said, for each object behaves differently. So we're just going to demonstrate, like traditionally, we're going to demonstrate a break after 5. This is stock standard. We have a counter. We obviously have a ton of processes that exceeds the count of 5. And we've just created a counter here. And we're just basically keeping track of that count. And once that counter hits 5, we're breaking out of the loop. So for each object, if you want to exit a loop with for each object, use break. That's completely fine. Now, breaking out of the loop standard, let's use return to iterate to the next item within the loop. Now that sounds weird. So if you were using a for or a do or something like that, you would use a continue. We're going to look at continue in a second. But if you wanted to basically iterate to the next item within the loop, and I'm going to use the word loop because the way the begin, process, and end block works, this essentially is a function. And so what it means is that when you hit return, it will actually return back to the parent, which would be for each object, and it will just iterate onto the next item. That's the reason why it works. So if you want to return, exit that current iteration and go to the next value, you'll use return. So we can actually see that here, and we just hit F8, and you can see here we've got a counter of 280. I'm just going to restart that. 277, and we basically printing out the counter. We're adding to the counter. So when the counter is equal or greater to 5, then we're going to move to the next item of the loop. And then I just added some extra code here. And we basically said when this code is greater than 5, it will return a trigger moving to the next item. This code won't be executed. And it just says I'm some extra code. Now you can see here what we're going to do. I'm just going to drop a breakpoint on this. That's fine. We can run this. It's not going to slow it down. So if we run this, it's hung. Is it? It's no. Has no configurations. Fantastic. Why is it thinking it's C#? It literally, I don't think, no, the reason why is because I actually hadn't ran, it's running PowerShell 7. I actually need to re-download the configuration for it. So essentially here, once OmniSharp, launch script. Yeah, I'm just going to add them all. Let's run this one. So we've got a breakpoint, let's run that. Okay, we can't. I'm not. How much time do we have? Yeah, I don't have time, unfortunately. So what we're going to do is we're just going to basically run this again, and we're just going to clear the screen, and we're just going to scroll up, and we're going to see this code be executed when the counter is not greater than 5. So essentially, if we run this, you can see there's no I'm extra code. But if we scroll right up to the top here, up to it's too much. Okay, so what we're going to do, I'm just going to change this demo so that I can actually demonstrate it. So I'm going to use select object, and we're just going to grab the first 2 items within that collection. And okay, here we go. So you can see here in 0, 1, 2, 3, that's interesting. 0, 1, 2, 3. Okay, yeah, it's okay. So essentially, you can see there before it actually hit 5, because once it hits 5, it won't do it. It'll stop on 4. It will basically, yeah, it'll write some extra code. And that's essentially how you would use a continue statement in a for each object. Now, let's get super weird now. Let's use the condition, let's use the continue, because why not? So if we use the continue statement, let's just run this. When we run it, we can see it just looks completely normal. It hit the count of 5. We're going to use the continue statement, and it just continued, like it just exited. So we can actually run that. We can just say right host, I exited, like so. So once we can, let's rerun that, and we can see, oh, actually that didn't work. Why didn't that work? Oh, actually it did. Let me just quickly clear that. Rerun that. Well, that's interesting. It actually didn't run it. Okay. That's actually another little life lesson. But essentially, it looks normal. Most people will be like, okay, it's exited, that's fine. But this is the problem, is because it looks normal until we actually nest some for each objects in it. Now we're going to see some weirdness. So what I've done here is basically I've set a counter. I've got a processes variable array that I've just declared. I just think it's easier to have an array, and we've basically got to count to 6. And then I'm iterating immediately. We're just using a default for each object, so there's no, we're not using any begin processor, and it doesn't matter. We're going to then print to the screen inside the first loop. I haven't entered the second loop yet, so like the other for statement, and when we're using loop labels. But now we're going to basically we're going to do another for each object. But rather than me declaring the variable, I'm just going to basically declare the array and then just pipe it immediately. That's totally fine. And now we're going to be inside the loop. And this is before the continue statement. We're going to basically use write output, because one of the things I want to do is actually want to write something to the pipeline. You're going to see why. And then we're going to run the continue statement. Now, I've put some code down here to prove a point that this code is never going to get executed. And what we're going to see here is the continue statement doesn't continue like it traditionally does with a classic for loop. The continue statement returns to the PowerShell pipeline. This is really important, because you can have, if you have a nested for each statement and you specify a continue, it will actually exit the parent for each as well and return to the pipeline. And that's significant. So let's run this, and we can actually see this run. And you can see here inside the first loop, we haven't entered the second loop, so we've called this line here. I can actually start a discussion right on it. Perfect. Now we're inside the loop before the continue statement, so we're here. And we basically then I've done this write output, and then I've called this continue statement. So what's going on here is now this is what's getting outputted to the pipeline. So we're explicitly saying we want to write this string to the pipeline. And then we're specifying the continue statement. And so what PowerShell is going to do here is it's going to, obviously, it's return to the pipeline. So it'll return to this pipeline. And because we haven't stored it in a variable or anything, it is the equivalent of obviously another write output, which will return to the parent pipeline. So essentially, we're passing this value all the way back through to the next value, back to the PowerShell pipeline. Now, that literally sounds like complete gobbledygook, but it's a big thing to know. You're never going to use it, but essentially it's going to be a gotcha. And the reason why is because if you have a multiple nested statement and you're wondering why the loop condition's not working correctly, that's why. It will catch you out. So essentially, like I said before, the continue statement will exit the entire pipeline. That's the pipeline for each object, and that's the pipeline for the parent. That is scary. So that's pretty much it for me today. And we know that that's the case as well, is because this code never gets executed. So yeah. So we're going to leave that for today. I hope you guys enjoyed it. Definitely very deep. It went a little bit longer, but that was because I had to have a few pit stops. But essentially, I think that was a really good session. Hope you guys enjoyed it. The next session, I'm just going to quickly end the show. We're going to discard all the ink annotations. Like I said, slides are up on my OneDrive, so you guys feel free to jump up on there and grab them. If you're not part of the Discord channel, definitely let me know. I might quickly post the link in now, and you can grab the slides from there. So let me just quickly jump into server settings. I'm just going to quickly grab it, generate an invite link. So essentially, you can just go to that link and you can join that Discord server, and that will get you sorted. So within that, basically, if you go to the notebook classroom, once you join, I can definitely add you. You can then go get the link. So that's pretty much that for today. Next week, I'm just kind of going through our kind of thing. We're going to be scripting with PowerShell. So this is going to be a single lesson. So I've kind of been introduced the fundamentals in terms of how to actually do the basic logic, and now we're actually going to be writing some code. So we're going to be setting some, this is going to be more of an interactive session. So in this session, we're going to be basically creating sets of objectives, and we're going to basically simple objectives, and we're going to be able to write code to be able to achieve that. So we're going to be, doing some whole bunch of different scenarios, and we're going to try and create, I won't say create a script, but basically just get the essentials for scripting. Once we've done that, then basically we're going to be obviously looking at debugging. This will probably be another lesson in itself. It might not be. I might combine it with using PowerShell to get around, because they're kind of a little bit, you can combine them. But we'll see how we go. We'll see how we go. But anyway, guys, if you liked it, obviously follow me for the new content. That's going to be happening next week. I think it's going to be next week, which is the 26th. I don't see why not. I'm not actually presenting at the PowerShell meetup, so I think I do have time to be able to do it. But essentially, yeah, next week's most is going to be scripting with PowerShell. We're just going to be writing some code, going to be setting some basic things, and we're just going to be kind of just writing PowerShell as a scripter. So we're gonna have a bit of fun with that. I hope you guys enjoyed it. Obviously, this is replayed on YouTube. You can watch it on Twitch for a period of time, and I think that's about it. So I'm not really anyway, if you guys have any other information or any suggestions, you can hit me up on Twitter. My Twitter handle is PowerShell Michael. Obviously, if you follow me on Twitter, you can obviously send me a message. But I'll see if I can grab my Twitter handle. That's it there. I'll just quickly paste it in the channel. And you guys can follow me on Twitter. So obviously it's also down the bottom there. But anyway, guys, I hope you enjoyed it. It's definitely always a pleasure to teach. I always think it's important for people to be able to learn. So yeah, I hope to see you guys next time, and bye for now.